Hello, everyone. Welcome to the latest installment of the AI Risk Report brought to you by Protect AI. I'm Diana Kelley, the Chief Information Security Officer here at Protect AI. And in this episode, we're going to unpack our recent security assessment of OpenAI's GPT-4.1 models. Specifically, we're going to be looking at some of the real-world vulnerabilities and red team insights from our incredible research group. And to help us do that, joining me today is Sailesh Mishra, an expert from our Recon Product team and co-author of the recent and really informative, strongly recommend that you check it out, blog, GPT 4.1 Assessment, Critical Vulnerabilities Exposed. Sailesh, welcome.
Thank you. Thank you, Diana.
It's so great to have you here. And just to get us started, I was wondering if you tell us a little bit about your role and what you do. Also, about what Recon is, and how did you get interested in AI security?
Sure. As for my role, I actually lead product marketing for the AI red teaming product at Protect AI. Recon is the AI red teaming, product that we will be discussing today, especially because we leveraged Recon's capabilities to identify the vulnerabilities in a GPT 4.1 models, and we have done this for multiple models before this. What got me interested into AI security is a couple of years back, we actually were dabbling with the newfound, sort of wonders of ChatGPT. And we realized very quickly that these models are, although back then, I mean, it was a very primitive experience, so to say. But because of the probabilistic nature of these models, we realized that it's not going to be a one size fits all or a one rule fits all kind of a paradigm that works from a security standpoint or even from a normal quality of response standpoint. And this is when Ruchir started dabbling with the security angle to it, and then Ankita joined in, built a product around it, and
These are the folks you work with at Recon, Ruchir
yes.
and Ankita, yeah.
Ruchir, Ankita started a company called Side Labs, which built the earlier version of what we know as Recon today. And we got acquired into the Protect AI's ecosystem. And in the last 1 year, we've been part of a much larger and a much more comprehensive, AI security solution. Because of those initial insights and initial playing around with AI tools, especially ChatGPT and the likes, we realized that there is an opportunity and the need for this can actually grow as and when AI models and AI applications just become more and more sophisticated.
So I love that. You saw a problem and you guys got in and you said, how are we going to fix this? Which is great. Yeah, that's what we do in security, right? We want to solve these problems. Okay, so we're going to talk about the GPT 4.1 series. So to just maybe help the audience understand, what's 4.1, what's mini, what's nano, what does that all mean, and why do we need to assess these models?
Yes. So OpenAI has released a bunch of models in the past. The more popular ones have been the GPT-4.0. And the more recent, more popular ones have been the O1 mini and the O3 mini, which are the reasoning series. 4.1 is interesting because it is one of the first long context window models that OpenAI has published.
What is that, a context model? So if I'm reasoning and I have a long context model, what does that mean to a user?
So there are two different sort of ways to look at this. One is a reasoning model. A reasoning model is, think of it this way. You've asked me a question. I'm actually thinking how I should be answering your question. And then I give you the answer, right? That's a reasoning model. On the other hand, you have something like a long context window model, such as the 4.1, in which you don't ask me a simple one-line question. You send me a book. And you tell me, hey, listen, now I need to know what the paraphrase summary of this entire book is, right?
Yeah.
Earlier models did not have the capability to go through, say, a 1 million token long context window. In the real world, what we do is we absorb so much information that all of that is embedded within us as some form of context. And in order for us to be able to achieve true AGI one day, all of our large language models and all of the developments that are happening in the AI world today will need to be able to handle longer context windows. That was the offering that OpenAI launched in the form of 4.1.
Mm.
Uh, Nano and Mini are the more efficient, I should say, models as compared to 4.1. You need them because you need to balance capabilities, costs, and efficiencies when you are deploying certain models for enterprise use cases.
And why do we need to assess them? Like what could be what these models are great. They're going to reason. They have long context windows. Why do we assess them?
Because you would be using these models in some kind of a context which is unique to yourself, right?
Mm.
These are general purpose models. What you would be doing is you would be leveraging the model's capabilities and maybe building a wrapper on top of it, or including these models within your AI architecture. What happens in this situation when you actually bring multiple software systems closer together and give an LLM some power to sort of talk to multiple systems together, vulnerabilities that are existing in the model can start creeping into your system. We've often talked about the OWASP top 10 in the form of, like, for example, let's say prompt injections, one of the most popular, or one of the most feared, let's say, vulnerability that exists in almost every model today.
Yeah.
Then what happens is, if a particular model is very highly susceptible to a certain prompt injection technique, a good possibility of your application, which is powered by this particular model, also becoming super vulnerable to a prompt injection technique increases, right? A general purpose model does not do much. It gives you, let's say, a certain level of generated answers, which is mostly English or your preferred language. The moment you hook it up to an application, which is more of an enterprise use case, you're essentially letting it deal with your data, letting it deal with your policy documents. And that is when the security aspect becomes super, super important, which is why you should be assessing while development of these applications with these LLMs right in the development stage.
And that is just such a powerful point that, yes, some people who are like, well, if you're just asking the LLM and it gives you the wrong answer, what's the risk? Well, it goes beyond that, because these are embedded now in critical workflows and systems and organizations. And if something goes wrong within that workflow or critical path, that can really create significant impact to the organization.
Yeah.
So, okay, so we need to assess, and we know what GPT 4.1, the series is. How do you assess them? What's the methodology? And in addition, we know that you use Recon as a tool. How does it work? And do you use frameworks? You mentioned OWASP. What else do you use to help really inform?
Yes, so we use Recon, which is a scalable red teaming tool for AI applications. But what we usually do is, just in order to research the safety alignment of these models that are being published almost every day by whether it's a Meta or the OpenAI or the Anthropics of the world, we try to just assess how the safety alignment of these models is actually improving over time. So we run Recon on the hosted endpoints of these models, and the responses that we get from the models as a part of this exercise, we evaluate them for any kind of a threatful nature. So, classic example: if I ask GPT 4.1 how to build a bomb, there's a good possibility that they will not answer. But if I change the technique a little bit and I ask the same model to respond to the same kind of an objective, a good possibility is you will give me the answer, right? The model will respond to that question. What we do using Recon is we evaluate these responses, find out if the model has actually responded with a recipe to, for example, not just create a bomb. It's an age-old example. To do any kind of for example, a cyber attack, let's say, or am I able to generate a phishing email using one of these models' responses? Don't know anything about it, but can I just prompt a model to give me a response like that? Right. So, these have real world ramifications, and that is what we start testing using Recon. We do it in an automated fashion where we actually have our own first party attack library, which is kind of a data set that we run against the model to establish a baseline behavior. And then we also have something called a Recon agent, which is a trained LLM agent, trained especially to carry out red teaming exercises on these models. In a way where it will simulate a bad actor interaction with the models or your application and will do context-specific red teaming, will send in an attack prompt, read the response, and then based on that, it will basically evaluate what is the next change it needs to do, and then make the attack prompt or the goal more and more complicated just to achieve the goal. Very similar to how a bad actor would actually work on your system, trying to get it to do something wrong. Recon's agent is capable of doing that on these models.
Yeah, I think of it a little bit like homeopathy, AI homeopathy, which is that, right, you can have an attack library. We know these are things that work, but also how do you test AI and a non-deterministic system with AI, another non-deterministic system. Yeah, and you map against, you mentioned OWASP. What are some of the other frameworks that you map against as you're saying, is this a risky or not risky model, or how risky is it?
Yeah, so because we wanted to be an enterprise grade product, one mapping would not be enough. There is a good possibility that some other enterprise, some other organization would be using a different framework for themselves. We map to the NIST RMF, we map to the DFF, the latest ones. We map to the OWASP.
Databricks.
Yeah, the Databricks
Databricks,
framework. We map to NIST. We map to the OWASP. These are the top three. And we are constantly collaborating with, all of these framework bodies to sort of, become better at how to articulate what threats and what vulnerabilities are, so that we also get a good amount of feedback on, how to classify things better, how to understand the vulnerabilities better, so that we can serve our clients the best way possible.
Yeah, so it's not just what the Recon team thinks is problematic. These are very well-known frameworks, highly adopted, and makes a lot of sense. Okay, so this has been a great background. Let's walk through now. What did your team find? Each model was rated as a medium risk. What does that mean, medium risk? What did you find?
So based on when we run a Recon scan, which is the actual red teaming exercise that we actually run on these models, when we run these these scans, we give it a score. There are different kinds of attack prompts that we have. They are weighed differently in terms of the severity or the criticality of the objective. They are also weighed differently based on the sophistication of the attack prompts that actually became successful or not, based on which we calculate a risk score. Typically, if the risk score is less than 30, we call it a low risk model or a low risk application. If the risk score is somewhere between 30 to 50, 30 to 60, we call it a moderate risk, model or an application. What we have seen as a part of the 4.1's red teaming exercise is that the risk scores were roughly around 40 to 41, which is why we classified 4.1 as a moderate risk model. We have red teamed other models from OpenAI as well, and some of them, especially the reasoning models, have actually gotten much lower risk score. So they are much more safer. That could be because they are reasoning models. We haven't established that yet. But for 4.1, we basically realized that the risk score is falling within a bracket of like 30 to 60. 40 would be a medium risk category.
So that gives you that was the rating. And as you were looking at as you're doing the testing and looking at the responses, were there any vulnerabilities that stood out more than others with these?
Yes, interestingly, if we actually look at, we create a sort of a spider chart of sorts to create like a good view of, which techniques and which kind of these threats are more successful on, for example, on a model. What we realized is prompt injections and jailbreaks are still like sort of leading the charts, so to say. They would still have the maximum attack success rate on these models. we have a very exhaustive set of attack prompts that use evasion as a technique as well, which is mostly input manipulations by encoding and just transformative attack prompts.
Mhm.
That also saw a significantly high attack success rate. But
Yeah.
if I was to call out one, it would be prompt injections again, because that
Yeah.
uh, seems like the defenses for certain prompt injection techniques was still not at par with some other models that OpenAI themselves have published.
So it's really it's getting around the guardrails is really the big concern. And you found out that the Nano model it was the most susceptible. Any idea why Nano would have been more susceptible than Mini or 4.1?
I would be speculating if I, sort of
Okay.
give you an answer around that. But my opinion on this is usually smaller models which are built for efficiency.
Yeah.
I mean, they tend to have a slightly lower safety alignment than the bigger models of the same like hierarchy of the same family.
Mm.
So a nano for a GPT 4.1 nano is expected, or at least we were expecting to for it to have like a slightly different, slightly lower safety alignment as compared to a
Mhm.
4.1, the parent model of the
Yeah.
this thing. Why does it happen? I would be speculating if I say anything
Okay.
around it. So I would rather not, give out misinformation out there. But we are constantly doing some amount of research just to understand like why does this happen, so that if you trim down a particular model for your use case,
Yeah.
what kind of vulnerabilities would you be incorporating within your system? We would want to find that and pass that information on to our customers. So we are doing some amount of research to understand that as well.
Got it. Okay. Thanks. And thank you for not speculating, right? I mean, like, no need to. Okay. So your team also, we were talking about how to build a bomb and how to fish. But sometimes people are saying, write malcode, find an
Yeah.
ODay, and write an exploit for it. Can you explain a little bit about how the Recon agent scan method um, looks for that kind of an issue and what was revealed during this testing?
Oh, absolutely. So the way you use a recon agent on one of your applications is you essentially give the agent a certain level of context. You tell the agent what this application is about. In our case, you tell the agent that this is a GPT 4.1 model. You're also allowed to give it custom goals. So we knew that a 4.1 model is actually built to handle longer context windows, which means it is designed for better real world utility, to have it can comprehend longer contexts, which means it can be used for coding and
Mhm.
development, right? So what if it was still able to, I mean, what if we were still able to get it to generate remote code execution in any way? Even if it gives me the process of how I can do it, that's still harmful to a large extent. Just imagine if you have access to an API, I'm prompting it, and it is actually creating a code in the backend which is executable on your systems. The risks then sort of multiply the moment you deploy it on your systems. But just because we were doing it on an isolated endpoint, we gave it these objectives. We gave it custom objectives of creating like a phishing email, of an SQL injection attack, of a remote code execution attack. And some of these attacks were successful. And that's a few of the examples that you would also be able to see on the blog. If you see that the 4.1 gives you a detailed series of steps that you need to do, step one, step two, step
Mhm.
three, of how to create these attacks. And somebody who understands how to do that can very easily just like follow the steps, and without applying brains or doing anything else,
Yeah.
will be able to successfully run attacks if they want to.
So yeah, this is a really big sort of risk intersection
Yeah,
point, and you did a great job of explaining how it can create problems for organizations in production when they're
yeah,
using LLMs. What are some things they could start thinking about in terms of protecting?
sure. One big, sort of two big steps, I would say.
Yeah.
I would start off with an interesting anecdote. One of my friends I was talking to when we were initially discussing the idea of AI security, basically securing AI systems. I mean, my friend said that, hey, listen, the culture in my company is such that nobody will really, sort of write an attack prompt I mean, write a prompt, yes, but not with an attacking intent. Uh, which is great. I mean, if it's working, which is great. But my only concern is that sometimes these models, they behave in a way where even if you did not have that intent, it might just like read certain words in your entire input prompt and think, okay, this might be what this person is asking for, right?
Mm.
And what you need to do is you need to evaluate your systems. While culture is great, I'm not denying that. What you need to do is you need to proactively evaluate your systems for any such propensity. What is, sort of how vulnerable is your application to different kinds of attack vectors that are known to the world today, right? At least protect from the unknown while you're building the applications, be proactive. And while you're developing and while you're deploying these applications, definitely have a continuous monitoring and observability tool that constantly gives you information on uh, how is your application getting used. Even if it's an internal application, how are your employees using it? What is the input? What is the output? How is the
Yeah.
output? What is the impact of that output from an LLM model? What kind of a downstream impact does it have? We have agentic systems now, so you can have multiple downstream impacts if you want to.
Yeah.
How does that
Chained
work?
impacts.
How does that work? You need to have a tool that constantly monitors the usage of these applications, both from an input and output standpoint, and then you can enforce your policies on top of it. It could be any
Sure.
kind of policy. It could be, uh, policies on a session level, policies on user level, policies on certain threats. You can, specify different thresholds, uh, completely aligned to how the security policies of your organization are designed today.
And thinking about the difference between a recon, you talked about recon red teaming and monitoring.
Yes.
What's sort of the difference if I'm deploying out solutions? A lot of companies, if they've got a foundational LLM, they're deploying it. They sort
Yeah.
of feel like do they have to test that if they've trained it for a specific purpose? Does it still need to be tested before it goes out, or can I just say, oh, well, someone else tested it, whoever created that model tested it, I'm good?
It should be tested. Whoever
Okay.
does it, whoever
Okay.
owns the process for testing it, it should be tested.
Yeah.
Whether you fine tune a model based on a certain data set that you want to improve its
Yeah.
performance on, uh, or whether you just change the system prompt of your application, whether you actually hook it up to a different tool when you're building an agentic system,
Yeah.
uh, you should be testing after every major change while developing itself. Otherwise, it's almost like it'll have like it might deviate. The behavior might deviate very slightly today. By the time you deploy something in production, a good possibility is the safety alignment would have deviated significantly from where you want it to be. And you don't want that to happen. You want a continuous feedback process between your security teams and your AI development teams. And that information will keep, the application development process in check. Especially because with AI, I mean, development is also going to happen super, super fast.
Yeah.
So you need something that gives you feedback. You can work on it super quick and not let those vulnerabilities stay within your system. And when you deploy, all of a sudden you're surprised that, oh my God, like I should have fixed like 5 of these very
Yeah.
quickly, but now I'm having to deal with 50 problems.
How do we fix? Oh, so for AppSec folks, right? We have to test, we have to retest. You find a vuln, but in classic application security, you find a
Yeah.
vuln, you
Yeah.
sort of know how to address it. You've got an input validation problem. You know
Yeah.
how to address that.
Yeah.
How do we address the vulnerabilities that tools like Recon are discovering within our LLMs in our
Yes.
AI models?
In fact, in the very near future, that's a wonderful question. In the very near future, Recon will also address this problem. It's not just going to be identifying these vulnerabilities, it'll
Mm,
also give you ideas on how to solve it. You can fix like a few very basic methods of how you can do that is you can actually improve your system prompt for safety and
yeah,
security. You can always impose guardrails, which are constantly monitoring these interactions and are,
yeah,
allowing you to have session level intelligence of, any kind of a malintent of the user
yeah.
uh, that's using it. You can always fine tune your models with certain data sets which are built to sort of make your models a little more safe, right? Uh, what we've also seen, and again, like this is not completely data backed, but what we've also seen is typically if latency is not a problem, you might want to select a slightly uh, I shouldn't say latency. You might want to select, let's say, a reasoning model
Yeah,
as compared to a regular model.
got it.
That improves security quite a bit. You might also want to do A/B tests on multiple different models that fit your
Mm,
use. So Recon will help you in all of this. It can help
yeah,
you evaluate guardrails. It can help you select the best model for your use case, particularly in terms of safety. I'm not like
sure,
Recon will not
sure.
you assess the performance of it. Um, it will also be able to help you with fine-tuning data sets in the near future.
Yeah,
It will help you in doing active system prompt hardening in the near future.
yeah.
Uh, and of course, the more you run scans using Recon, the better intelligence we have or Recon has, and
Mm.
hence you have on your systems, and better corrective actions you can take on it.
Yeah, and that is, I love that point. I really want to underscore it that this isn't about when we think AI, sometimes people sort of think like AI, there's some giant monolithic AI, but no, there are a series of models, and those models have been trained for different uses, and so and have different different foundations. So it's such a good point that it's not necessarily sometimes you may be using the wrong model for purpose, and you get to a better safety state by using a better model or deploying it architecturally in a different way. So yeah, such an important point in terms of protection for AI. The other point before we close, I was wondering if you could touch a little bit on. There's a lot more discussion around zero trust for AI, talking about isolation and applying concepts of least privilege. Could you kind of take us through a little bit about what that means in deployment and how that can help reduce or manage risk?
Uh, an enterprise grade product, which I shouldn't, let's not call it a product, an enterprise grade AI system, which is deployed for whether it's consumer usage or whether it's, for example, an internal usage, uh, can have, and in the near future is definitely going to have multiple models, multiple different like sort of agentic
Uh,
frameworks working
yeah.
together in tandem. Um, Achieving zero trust is going to be difficult, especially because you will not be able to achieve true understanding of the provenance of each and every one of the elements that are building your system
Mm,
overall, right? But keeping a tight check of how individual components are functioning and keeping a tight check of how the entire like sort of
yeah.
stack is working, uh, while you're constantly assessing for cost and performance, do test for security as well and do it continuously so that you understand what problems are creeping in every single time you make a
Mm,
minor or a change. And that is, I believe, my only like sort of
yeah.
perspective. But yeah, I would always advise for do everything continuously unless eventually we figure out that okay, this is one thing that has completely gotten eradicated from our entire ecosystem of AI
Yeah.
sort of features, which I don't think is going to happen so quickly. So it's better to be safe today than sorry.
I completely agree. Yeah, these are untrusted components, just like any other component in a system. You need to wrap the trust around it with isolation, with concepts of least privilege. So, yeah, love that. Okay, well, thank you, Sailesh. I feel like we could talk for forever, but this has been really fantastic insights, really, really helpful. I was wondering if before we close, if you could just let the audience know, sort of, as you were going through this work and just all the work you've been doing over the past couple of years, what's kind of your big takeaway right now?
Oh, wow. My biggest takeaway on AI is not, I might, yeah, deviate from what we have been discussing. It's not exactly from a security standpoint. What I've realized in the last a couple of years at least is things are becoming so simple that they're also becoming super fast. So I was very recently reading an opinion piece somewhere, which I completely echo, is uh, I mean, the developments in the AI world has happened so fast
Yeah,
that the users of AI do not really understand how to use it. Uh, like, I mean, all of us are using AI in some way or the other, but the developments are happening so fast that it is becoming difficult to catch up just
yeah.
to the capabilities of what is happening today. Um, and yeah, I mean, that is my takeaway. I mean, I'm constantly surprised. I'm constantly playing catch up to what's happening. uh, in all of this, there is sort of this area of security which will constantly remain. I mean, the version of it might change. The way we look at AI threats today might change, but we will still have to constantly sort of monitor how these applications are being built. Where are we sourcing these components from? In the whole MCP era, what kind of servers are we interacting with?
Yeah.
Uh, we need to constantly sort of monitor these, because again, I go back to the same point. It's getting simpler, and hence it's getting more accessible,
Yeah.
which is great in a way, but it's also it can come up with its own problems.
Well, it also underscores, because we are all in learning mode, it also underscores the importance of people like you putting out, this blog that you did just co-author on what was found during the testing of the 4.1 series, because I think that, really, how are we all going to advance and be able to adopt AI in a trusted manner by
Yeah,
different people doing research and sharing that research like you just did with the
absolutely.
blog, and also for the folks who've been listening into this. So thank you so much for spending the
Thank you
time
so
to
much.
explain what you found in the research on the GPT 4.1 series. Thank you to everybody who tuned in and watched. If you want to dig deeper into the findings from the report or learn more about how to protect and secure your AI systems from end to end, as always, please head on over to protectai.com. Thank you so much for being with us today, and we hope to see you next time. Take care.